Hello all, welcome to i-tutor Academy. In today's session we will start with the unit 11, that is computer programming and languages. Okay. So what is the structure of this unit? There is an introduction part. Obviously there is an introduction and objectives are there, programming vocabulary, control structure or control statement, overview and features of Visual Basic, and overview and features of Java, overview and features of HTML, overview and features of Excel. It's all about computer language and programs. Okay, this chapter, and summary is there, self-assessment exercise also there. So let's begin with the introduction part. So we know that to communicate with a computer we have to write or code in computer language, okay, in terms of instructions to the computer. It means that for any problem to be solved by computers, we have to write a program for solving the problem. A computer program is the set of instructions or statement written in any computer programming language. And programming language is the only means by which we can communicate with the computer. In other words, computer programs work as an interface between a person and a computer. There are many computer languages to write programs. Broadly, they are categorized as low-level language, example machine level, assembly level language, and high-level language. Like all of you maybe know C++, C, Basics, Python, Java. All these are common computer languages. Okay, so low-level languages is hard to learn. A computer program are required to be coded in 0 to 1, and similarly assembly level is also not easy, as programs are required to be written in that is in a coded way, and both these languages are machine dependent, and they are used by expert programmers. High level programming languages are easy to understand and learn, as they are written in English like a language. What are the objectives of this chapter? There is an explain in the vocabulary used programming languages, identify and describe control structure in programming languages, identify important features of net, VBNet and Java, HTML, XML, Excel and Python, and write a program in higher level language also. These are the objectives of this chapter. So next is programming vocabulary. So suppose we want to write a program for finding factorial of numbers. So the flowchart of the pseudo code for this will be, there is start, there is enter n. These are the, you just go through this figure. So this is the way for the programming a vocabulary. Okay. So step 1 is there, step 2 is there, 3, 4, so like many steps are there. Okay, so in writing above program we have used some important words such as if, then, else, repeat, until, or input, print, declare, etc. So respective meanings inherent in these words form a fundamental concept in programming. These words are called reserve words or keywords of the programming language. To write program in any language is simply a matter of learning its syntax and semantic rule and special features. While syntax denotes the grammar rule, semantic denotes the meaning associated, and n denotes the number for which factorial is required to be obtained by the computer. And fact denotes a calculated factorial of the number n during the execution of the program until the end. And apart from keywords, a program uses several other programming concept with identifiers, constant, expression, library function, etc. These concepts are defined here below. Identifiers, they are the name given to various programs elements such as variables, functions, subroutine, etc. Identifiers consist of letters and digits in any order except the first character must be a letter. Variable are those elements of program whose value can change during the execution of a program. Both n and fact used in the figure referred above are variable, as their value are changing after each computation. Constant are those elements of program whose value cannot be changed during the execution of the program, means they have fixed value. The numeric constant can be integer, representing whole number or floating point number with a decimal point. Constant would be probably the most familiar concept to us since we have used them in doing everything that have to do with the numbers. String constant are sequences of a alphanumeric character, combination of alphabets and numeric enclosed in double quotation marks. Example, computer x123. String constant can be concatenated and compared in lexicographic sense. And expression, an expression represents a single data item such as number of a or a character. The expression or may consist of single entries such as constant, a variable, an array, or a reference to a function. So generally, every high-level programming language provides some set of arithmetic, relational, logical operation. For knowledge about computer program, you should be aware about these basics. The most common arithmetic, relational, and logical operation, as we all know, are arithmetic operation, relation operation, logical operation, and like that. And here is logical operation, examples are there. Okay, so in above expression, exponential operation is evaluated first, then multiplication and division operators are evaluated, and lastly the addition and subtraction operator are evaluated. The precedence of arithmetic operation is exactly the same as in mathematics. That is, computer follow BODMAS, bracket of and division, multiplication, addition, subtraction. If the expression contains exponential operator, then it is of highest precedence and it is evaluated first. And relational operators have same level of precedence among themselves but low precedence than arithmetic operators. Logical operators have lower precedence than relation operations. Among themselves, they have the following order of priority during evaluation of logical expression, and like that. So note, there is NOT is represent highest precedence, or XOR, that is lowest precedence, like that. Expression would be our basic workhorses and our programs would be full of them, and while executing the program, computer would be preoccupied most of the time to evaluate them. And but it would also be doing other things such as taking some values as input from input devices, assigning a value or result of an expression to a variable, send a value for display to output device, pondering to be or not to be on some conditional expression, repeating some task, and until we are satisfied, and calling some slave program to perform specific task. And the following discussion we shall elaborate on this action, and generally every high level programming languages has got some built-in data type statements, etc. They are illustrated here. Programming languages are divided into two, that is built-in data type statements are there. Built-in data type, there is itutor, chr, real, boolean, etc. In statements, there is input output, declarative, assignment, control, and next control is again divided into branching or selection statement, looping, iteration statement, and jump statement. And jump statement again divided into break, go to, continue, etc. Built-in data type and statement type are specific to a particular programming language. Built-in data type, generally all programming languages support following type of built-in data, and int is, that is whole number, and real, there is number with a fractional part, and data type which is either true or false, and char, there is single alphabet or a numeric character enclosed in single quotation marks, and string is group of character enclosed in double quotation mark. And before using any variable in program, it is generally necessary to define its type, and broadly known as data type. The computer memory requirement for each data type is different, and it is independent upon the specific programming language. Statement is divided into declarative statement, input output statement, assignment statement, control statement, or control structure. So declarative statements, these statements are used to declare the type of the variable. So example is here. and they can be broadly classified as console on screen input statement, file input statement for giving input in a file, and console on screen output statement and file output statement for getting output in a file. Console input is used for taking the input from default input device. Example step 1 is here, and figure 11.1b. Similarly, the file input statement are used for taking the input from file or non-default input device, while a file output statement is used for writing the output into the specified file, like that. And next is 11.4, that is control statement or control structure. The execution of computer program is always sequential, and statement which is written first will be executed first. To change the sequential execution of program, we need control structure, which can be broadly categorized as follows. There is branching or selection statement, looping or iterative statement, and jump statement. And branching or selection statement, they are used to select one group of statement or single statement for execution from several available groups of statement, and the selection of a particular group depends on some boolean condition, example if, then, else, etc. So this statement is used when we have to make selection from two available groups of statement, and S1 group of statement will be only executed if boolean expression is true, otherwise S2 group of statement will be executed if boolean expression, that is S1 statement, else S2 statement is there. Entry boolean expression is there, and again it's group S1 statement and group 2 S2 statements. Case statements is used if we have to make a selection from several available groups of statements. And here x, y, w, z are permissible value for expression r. If expression r evaluates to value y, then S2 group of statement will be executed if expression r evaluates to non-permissible values. None of x, y, w and z, then default and Sn group of statement will be executed, like that. Looping or iterative statements. A computer is well suited to perform repetitive operations, and it can do it tirelessly, and every computer language must have features that instruct a computer to perform such a repetitive task, and the process of repeatedly executing a block of statement is known as looping, and the statement in the block may be executed any number of times from 0 to infinite number. If a loop continues forever, it is called an infinite loop. Finite loop is a loop which terminates after fixed number of iterations. These fixed number of iterations are known to us in advance. For implementing finite looping, we use for loop structure. So for variable x is equal to value 1 to value 2 step size value 3, s1, s2, s3, sn, body of the loops, and end is there. In this case, the variable x is initialized to value 1. Then it checks whether the value of variable is greater value 2, and if not, then it executes the body of the loop and then increase the value of variable by step size equal to value 3. And if we do not know in advance how many times the loop will iterate, then we use while loop or repeat until structure, and their type of loops are terminated by some boolean expression. The body of these loops must contain one statement that alters the value of the boolean expression, that is there. And a jump statement, go to, break, and continue are generally the jump statement. Go to statement is used for jumping from one location to another labeled location within the program, and break statement causes the loop to be terminated, and the continue statement causes the loop to be continued with the next iteration after skipping any statement in between. Functions or subroutine and subprogram modules. There are two ways to write a large and complicated computer program. One is to write the single program if we can, and which are normally very difficult for a large and complicated program, and the other is to look at the large program as consisting of several somewhat less complicated subprograms. Copying with each of the subprogram can be seen in the same manner as main program. Either write then directly if we can and or refine it in terms of the further subprograms and so on. The process of breaking large and complicated program in smaller and less complicated subprogram is known as modular programming approach. Each subprogram is termed as function, routine, module, etc. depending on the specific programming language used to write the program. Okay, so this is about today's section, and for more topics, for MBA topics, you just do like, share and subscribe our channel. Thank you so much.
i-tutor Academy presents Ignou MBA complete syllabus coverage classes for individual students, semester-wise subject with online and flexible timing. For more details, contact on +916 238 21785.